Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Dr. B, welcome. Thanks so much for joining the show here today. It's we've known each other for a little while here, and we're working on some projects together. But your career is absolutely amazing. It goes back. I think you were 38 years at Daimler-Benz as like the first sort of non-German VP of R&D for cars, and now you have a career as the professor, executive director, I think at the Center for Advanced Vehicle Technology, right at the College of Engineering, University of Alabama, and I see you're wearing your shirt there today with your University of Alabama colors, and welcome. Just thanks for taking the time to be here today, and it's great to be talking to you again in this format.
Thank you for inviting me.
Thank you. Well, I'm thrilled to have you on, and I just wanted to kind of just dive right in because you've spent such a long, illustrious career in sort of the automotive world. Just kind of, I always like to find out what inspires sort of the young mind if you can go back to your earliest days as to what made you want to pursue a career in cars and automotive engineering? What was your early inspiration?
Paul, it goes back a long time back. When I was a young boy, I was interested in anything that moved. So I was interested in planes, cars, and trains. And above all, I was interested in their engines, so the gas turbine, the electric motors, the internal combustion engines, etc. At the age of 13, I grew up in Bombay, and for 3 years we went to Calcutta, and there I became an avid reader of car magazines and railroad magazines at the British Council Library in Kolkata. And that sort of fired my passion even more. During those days, in American and UK magazines, automotive magazines, they were all in praise of Mercedes-Benz and their innovations and their technology, especially related to engines, as also related to safety. Mm-hmm. So at that time, at a very young age, I made a decision that I would be going to Mercedes-Benz and working with R&D. So this was at the age of around 14, 15. I came back to Bombay, finished my high school, joined IIT Bombay. That's it's the top engineering school in India, mm-hmm. and one of the top 100 in the world. Did mechanical engineering and also did a lot of work on automotive engineering. And after finishing IIT Bombay, it was a 5-year rigorous honors course. I took a year off, did 6 months of intensive German, and then on April 21st, 1974, went to Daimler-Benz, to Germany, to Stuttgart, and since then never looked back. So wow. Those were very interesting years. Starting in 74, Germany was totally different from what we see today. More importantly, I worked in the first 3 years. I got my master's. I worked 18 months at Daimler-Benz as an intern in R&D and 18 months at the university. So it was always every semester holiday I was working at Daimler-Benz in the R&D division. And I finished in 77 May. And it was a very interesting experience. My picture and idea of what German engineering looked like, it came truly the way it was that I had imagined. The professors had tremendous applied engineering knowledge, which was not the case in India, and which is partially not the case here also in the United States. So there, uh, it was a tremendous ride for me. The amount of knowledge I got there. Above all, the professors have a lot of industry experience. In the German system, you have to have worked at least 5 to 10 years before you can become a university professor. Secondly, the connection between university and industry is extremely close. So I had five professors from industry who were teaching me automotive engineering. Uh, the the senior VP of research taught me automatic transmissions and became my advisor for my PhD. So he was an adjunct professor. The exec VP of ZF R&D, ZF is the second largest world supplier, automotive supplier. He taught me vibration systems. But the coolest guy was the CEO of Daimler-Benz, who taught me car body engineering. Now, this is all unimaginable in the USA, that the CEO of GM or Ford goes every Wednesday afternoon to a local university and teaches a course and comes back and holds exams, etc. But that was the way that was done. The good thing that came out of it, besides the tremendous knowledge these guys had, was the senior VP of research asked me whether I would like to do a PhD and stay on at Daimler Benz. And since that had been my original intention, I joined as a full time employee in 1977 in May, and then continued at Daimler Benz, did my PhD in parallel, and moved up the ranks. Now, Germany at that time was very, very traditional, as I said earlier. It's not the Germany or Europe that you need know today. There were few foreigners. Uh, the few foreigners that were there were originally recruited as guest workers, Gastarbeiter, as Germany went into a boom in the 60s. And they didn't have enough people after World War II to work the factories. So they had a huge recruitment of Turks, Italians, Greeks, and Spaniards. But they were all typically on the assembly side, blue collar workers. On the white collar workers, there's very, very few. Now in the second generation, it's all, and third generation, it's all come up. But anyway, it was a fantastic time for me. And all that I had imagined about German industry and German engineers came true. They had extremely deep knowledge, which is very different from what I have seen both in the US and in India. And we can talk about that difference later on. And I
No,
moved up the ranks.
that's
Yes,
interesting.
please.
Yeah, no, I mean, first of all, it's fascinating that you, as you know, as early as in your teens, sort of have this vision for what you wanted to do, and then you realize that not a lot of people get to do that, and so that's that's an interesting story in and of itself. And there's so many questions popped up around that, but I guess just kind of focusing on that deep engineering um, concept for a moment. What is that? What is it that the folks with whom you were working at the time, like what constitutes deep knowledge? Was it just like deep technical knowledge? Was it sort of the business side of things? It was the combination of everything. I mean, it sounds like it was sort of the technical infrastructure behind the vehicles, and I guess that's not the case in sort of other sort of companies or organizations. It sounds like.
Yeah, I think that's probably a cultural issue or a cultural advantage that Germany has, and which I see here with my students, the American students and the German exchange students who come to me here. Uh, in the German system, we all have tremendous practical knowledge, and we are able to combine this practical knowledge which with a theoretical mathematical simulation world. And what I see with German students and with Germans in general, we can move seamlessly between the mathematical simulation world and the real physical world, or vice versa. So if there's a phenomena, a vibration phenomena in a car, we can translate it quickly into a mathematical formulation. Or the other way around, when we do some structural optimization, we can translate what the finite element analysis is telling us into the product, how it would impact the product design. This seamless knowledge between the theoretical world and the real physical world, I find is very outstandingly utilized in the German society. And it's not just automotive engineering. You can take chemical engineering, electrical engineering, etc. And that is what I found out in the last 12 years, the difference between the American and the German education system. What the American system is outstanding is encouraging people to go after big ideas. The German system does not encourage you to do it. All the top guys, including me, we just wanted to follow our passion in deep technical engineering world. We were never interested in disrupting the world and becoming millionaires or billionaires. So the number of startups that you see in Germany are pretty few, and they are not very dominant as against what you see on the West Coast, especially in California, as also partially on the East Coast. Number of people who are starting new ventures, including you as Perrone Robotics, who go into a lot of high risk area instead of going into a very settled, technically oriented engineering career.
Yeah. It's interesting because it's this sort of balance between the theoretical and the applied or practical, whatever you want to refer to it as. The theoretical framework kind of provides an envelope and a concept framework within which you operate. And if you're creating something new, right, if you're trying to discover a new idea, I mean, obviously that can be done in sort of with theoretical work, but that may be binding your actual implementation to just sit within that theoretical envelope. So I guess that's sort of a question, because when I went into, I did my PhD work in safety critical systems design, right?
Mm.
So I had some formalization there with how we approach development of software and hardware for safety critical safety assurance um, methodologies in mind. But on the flip side, when I got into autonomous vehicles, it was very much almost like a do not pass go direct shot from what I had been working on at the time with middleware software as at the professional level to this autonomous sort of vehicle space and robotics sort of combined. And um, and and I did and while I had some theoretical framework in robotics and certainly control system at the time, way back in my college days, when I was first getting involved in this at a professional level, I wasn't bringing that to the forefront, so I didn't know what really the limits were, right? Like like what was possible or not possible, and I wonder if there's if that plays into how one innovates in this space, right?
I think both approaches, Paul, are legitimate and can lead to outstanding results. If you're on the software side, the theoretical world is probably much more impactful, and you see it with all the software like the Microsoft Windows environment, the Office environment, Google search, Facebook, Instagram. On the software, the American society, the American engineering is really dominates the world. But on real products, it is equally shared between Americans, Koreans, Germans, and Japanese in high quality, high tech products. And slowly, China is also coming up. I think both approaches are valid, but it's also interesting to know in a cultural context. If you look at the number of Nobel Prize winners, the US ones are typically in theoretical sciences. In Germany, it has always been experimental sciences.
Hmm.
And all the big names like Max Planck, Leibniz, etc., Helmholtz, they were all experimental scientists.
Right.
Yeah,
Right.
it has something to do with the culture, and I would not say one is better or the other. They are different approaches. The way we have grown up in society, certainly in the automotive world, since we are bringing out a real product, the applied engineering knowledge becomes more relevant,
Hmm.
and that is something that American car companies seem to have lost the touch over the last 50 years, and I say it cautiously.
Sure. Well, actually, so like, what are your thoughts on like what happened? Like, yeah, what happened there over that time period?
Yeah, let me take a step back and give you first a bird's eye perspective. If you look at the three systems, Japanese, German, and American, in Germany, we are extremely engineering driven. So if you look at the CEOs of BASF, of Bosch, Continental, Delphi, not Delphi, Mercedes-Benz, BMW, Volkswagen, they're all engineers, even at the CEO level. My former CEO was a PhD, 1 year junior to me, who studied also in Karlsruhe and did his PhD in analog sciences. So all of them have deep engineering knowledge. If you look at the Japanese system, they are very manufacturing oriented. So the guys who are at the top, who call the shots in the product design, they're the manufacturing engineers. That's why Japanese products have a tremendously high quality. So if you look at Lexus, and Toyota or Honda, extremely high product quality, very few design defects, very few defects on the field, because their manufacturing excellence is driven by people who are in high positions to influence it.
Yeah.
And if you come to the American, unfortunately, and this was to be seen by GM and Ford, they're driven by marketing and sales and finance. So the bottom line, they're constantly driven by the bottom line. And I can say it from an insider perspective because when we merged with Chrysler in 1998, uh, there were two distinct cultures. We from Stuttgart, the engineers, we were always driven by let's make the next big innovation in the product. Chrysler was what does it cost?
Right.
Yeah, and will our customer base accept these innovations? And I think that is part of the reason why the American car companies and their suppliers slowly lost out to the Japanese, Koreans, and the Germans as far as product innovations was concerned.
Yeah.
And they were content to become a fast follower and pick up through their supplier base the innovations that the other companies did. And today, 50 years ago, 60 years ago, Cadillac was truly a luxury brand. Today, it has a lot of difficulty competing with BMW, Lexus, Audi, and Mercedes. You know, they have a lot of, they try to find a brand identification which says what is unique about the Cadillac brand and have tremendous challenges there. And I can also say from my youth, I used to admire GM research labs. It was huge, it was extremely powerful, extremely innovative. The same with the IBM research labs, with the Bell Labs in New Jersey. They were all tremendously talented, outstanding research work. But for some reasons over the years, they were slowly decimated, and none of them exist in their former form today.
Yeah. It's interesting. I mean, it almost should be at this point like a documented rule in business books that this is a fact because even Steve Jobs made some mention. I'm not gonna quote him perfectly, and I believe it was him. He said, when a company you see a company start out with an innovator, an engineering oriented sort of CEO, and then once they have a marketing again, then they go to a marketing CEO. They're kind
Yep.
of they're kind of going in the wrong direction. And once they get the finance CEO, they're only going to live a few more months or something like that. and
Okay.
and it's funny, but yeah, in other industries, of course, well, even in the automotive industry, you have, as and him, Elon Musk, right? Very
Mm.
innovative person behind Tesla. You had Steve Jobs at Apple. You had who was a more technical but also a marketing minded individual. But then he was replaced with a marketing sort of
Mm.
oriented CEO, and Apple took a turn for the worst, and then he came back. And then, like, the likes of Larry Ellison at Oracle, all these companies that have these, um, and CEOs with the sort of the engineering background, but also they have to have some interpersonal skills and
Yes.
communication capabilities that not all engineers by training have. So it's a special blend, I think, of but they have to have that background of innovation, I think.
So if you ask me, then in summary, Germany engineering R&D driven, Japanese manufacturing driven, US finance and marketing sales driven. And that sort of is true for almost the entire industry. And that reflects on the innovativeness and the products that you get out if you're doing real products. Of course, there are exceptions to this rule. If you look at Apple, deep vertical integration, tremendous R&D product knowledge, very little manufacturing in-house, but tremendous knowledge of managing manufacturing in distant locations like Taiwan. So it's a sort of exception to the rule.
Yeah. Well, it seems like you need it all, but you need the right balance of these things, right? I mean, you need R&D, you need innovation, you need to have a good manufacturing process. It needs to be economical. In fact, I guess Elon Musk said that was one of the most difficult things about making the electric vehicle company Tesla is, getting the manufacturing right. You know,
Yeah, but yeah, when I worked with Elon Musk for over 6 years and we knew each other extremely closely, he was engineering driven, pure engineering driven. He had a vision for an electric car and he wanted to go after it. And at that time, somewhere after the first couple of years, I told him it's not going to be electric cars, but it's going to be self driving cars, our topic today. And that's how it turned out.
right.
Yeah, today his value proposition is self driving cars and not really the electric car because everyone has electric cars now, every manufacturer.
They do, but I guess can you comment a little bit just on that electric vehicle topic? Not all electric vehicles work well. And I'm speaking from sort of a different world where, it's not necessarily consumer automotive vehicles. There's some vehicles that are non-consumer oriented, larger vehicles, different construction vehicles, what have you, that they attempt to make electric, and the scale for manufacturing isn't always there, and so there can be reliability issues, right? So are you saying, like, in the consumer auto space, that, I mean, who else has I mean, is Ford are they having success with their electric vehicles? GM, can you comment on that, on these other companies?
Probably right now, not. I'm being cautious. The American companies in the electric vehicle world are not very successful. Uh,
Why is that?
I think there are a couple of reasons. The first is Elon Musk introduced the electric on cars, not on trucks, not on light duty trucks, and not on heavy duty trucks. In cars. In cars, the value proposition, the range, the size of the battery is much easier to fulfill. And Teslas have shown us how far you can go. And traditional automotive companies like Mercedes, BMW have picked up the challenge. And it's very interesting to see how well they have managed the challenge regarding range, efficiency, etc. So if you look at the EQS 580 Mercedes S-Class sedan, it has a range of over 400 miles. My car started with about 360, and slowly it crept up to about 420 miles. And that was last year's model. This year's model is probably more around 450 miles.
Hmm.
So tremendous range, tremendous quality of build, quietness, cabin quietness, soundproofing, ride comfort, etc. Uh, this has made them competitive. They are still not earning that much money as against a combustion engine car. So if Mercedes sold you a S580 combustion engine, they're going to make much more money than if they sold you the 580 as an electric version.
Yeah.
This is because the price digressions for the electric motors, for the battery pack, for the inverters, etc., have not yet reached the stage of what you have with the V8 combustion engine.
Hmm.
There, everyone has a 100 to 120-year head start on optimizing the manufacturing of these components. So sometimes people say, IC engines have so many components, hundreds of components, they just can't be as cheap as an electric motor. That's not true. The electric motor has only three main components: the housing, the rotor, and the stator. But still, if you take it all together, including the battery pack and the inverters, there's no cost comparison. It is way off from a fully technologically equipped V8 engine. So that has been a challenge. Uh, and American car companies, coming to your earlier question, they forfeited the passenger car market. I think there's only one which really still is in it. It's the Cadillac. And with the Lyric, they offer an electric vehicle. They're all concentrated on light duty trucks. And that's a totally different clientele. And I'm sure the Ford F-150 electric is a tremendously good vehicle. But if you're a hardcore light duty person and you value the money, it's much more straightforward to get a big V6 or V8 engine and stick to your traditional Ford. Yeah,
Yeah.
you get all that you want, the range that you want, gasoline is cheap, etc., etc. So you're trying to attract a normal customer into a higher technology level, which really does not offer him any added value.
Yeah.
Not more towing capacity, not more range, no nothing other than to say you're driving an electric car. And I don't think people who drive SUVs want to do something good for emissions. If you really wanted to do something good for emissions, you drive a smaller car. And so car customers are typically much more prone to accept and buy electric vehicles, which shows the number of the success that Tesla has had. It has disrupted the normal vehicle market. But on the light duty vehicles, on SUVs, on trucks, this is just not the case.
Yeah. Are we getting the benefits of the sort of the clean energy facet of this? I mean, one reason to go to electric. I mean, I think there's good technical reasons to go to electric, for the simplicity and just other facets that you mentioned. But sort of zero emissions is important, um, and kind of clean energy methods. But then when they take it home, they're charging off the grid, and are we getting the benefits of that? Because maybe it's a coal powered plant or something, right? That's actually delivering the energy to this vehicle.
Yeah, so Paul, it is only partially true. When you do an apples to apples comparison, you look at the cost of manufacturing, the CO2 emitted during manufacturing, and electric cars emit a lot more CO2 and consume more energy during manufacturing because of the battery pack, etc.
Mhm.
Nevertheless, if you take the total life cycle CO2 emissions or energy consumption, electric cars are ahead, uh, even when based on different grid types. So I have charts on that. Even if you look at coal-fired plants with a typical mix of about, I think the United States is about 40% coal-fired. If you take the CO2 and include it, still electric cars come between 10 and 20% better over the total life cycle. Now, this equation is dramatically changing in the coming years, especially in Europe or in Germany, where the amount of renewable energy in your grid is increasing.
Hmm.
And once that starts increasing, uh, this advantage of electric cars, which is today perhaps only 10 or 20% on the CO2 side, life cycle oriented, is going to dramatically increase over the years. And there's no turning this clock back.
Right, right. Do you think like I mean is some folks have touted, that hydrogen fuel cells and what have you might be sort of the way forward. What's your thought on hydrogen versus electric as sort of maybe distinct paths or concurrent paths forward for powering vehicles?
So let me quote from my 2006 to 2012 experience. In 2006, I was already a VP at Mercedes-Benz Research and Development, but primarily design and development. I was also made head of research for the Daimler-Benz group, that was passenger cars, Daimler trucks, and Mercedes-Benz vans. At that time, I did a tour of the world, especially Silicon Valley, and I was extremely convinced that electric cars were much more viable than fuel cell cars. And that's the time I met Elon Musk, picked up the collaboration with him. He and I became close friends. And I tried convincing Mercedes Benz and my colleagues there's more potential, immediate potential in electric cars, uh, and fuel cells are a long way away. You, Mercedes Benz in the first generation of the A class and the second generation of the A and B class, we had a sandwich flooring. It was about 12 inches high, and that could accommodate either a battery pack or a fuel cell stack. We made the vehicle that way. But we never outfitted it with a fuel cell stack other than in prototype cars. And Elon Musk, sometime in 2007, 2008, took a vehicle from us, removed the IC engine, and put his battery pack in it and allowed me to drive it in San Francisco. It was fantastic. It was because the A class itself was a solid car, solidly built, and he had added electric drive to it. There was no changes to the car body because the sandwich flooring had been designed for battery packs. It was fantastic, really fantastic. But even though he and I thought greatly of each other, our company's engineers were not very enamored by each other. And I think there's a certain arrogance. The Silicon Valley engineers at Tesla thought they were the best guys in the world, most innovative. And my colleagues in Stuttgart, we always thought the Swabians are God's gift to mankind for my automotive engineering. So, although Elon and I got along famously, the teams were always at loggerheads. The only good thing that came out of it was the first smart electric vehicle had the Tesla battery pack, and the first B class Mercedes Benz vehicle also had the Tesla battery pack. And all the tests that we did were very impressive. They were better than our own in house designed or in house supplied battery packs. Later on, then we switched to other suppliers, etc. But coming back now, I seem to have lost my thread of thought. We were talking about
Well, I was just gonna, yeah. While you regain that, I was just gonna give you a quick little blurb here. My first exposure to
fuel cells, fuel
oh,
cells,
fuel cells. Yeah, yeah. Go ahead.
fuel
Yeah,
cells. So let me come to that.
yeah, yeah.
So I tried convincing the heads of Mercedes-Benz, the CTO, my boss, and the CEO, why don't we do electric cars first and then fuel cells second? Because in the fuel cell, it has an electric motor, it has a high voltage battery with a lesser capacity than battery electric vehicles. It has the inverter, and we had the knowledge for all three. And we could have got out an electric car within a year or two. But the CEO and CTO were more vested in fuel cells. And my feeling was that we would never be able to get it down to a cost level which would be competitive with electric cars.
Hmm.
And Elon Musk showed that way. And things changed dramatically when a new CEO, Ola Kalenius, came to the company and took over charge. He was previously, he did a stint as a R&D head and sales and marketing head at Mercedes-Benz, and then he became CEO. And one of the first things he did was he he took away, when we separated the Daimler group, he sent the fuel cell group to the trucks. So Daimler Trucks now has the fuel cells, and that was a wise decision, because today I am I am very confident it's very difficult to turn back the clock and say we'll do passenger cars with fuel cells. That race has been won by battery electric vehicles, including the infrastructure, the comfort, the home charging, the fast charging, etc. No one is going to set up an additional infrastructure for hydrogen. And the costs of an electric car are going down year after year. And my personal feeling that a fuel cell will never be able to match it.
And do we have
So
the
that,
natural resources on the globe to, for the cobalt and all the things that kind of make up these batteries, at for ultimate scale of however many, how many vehicles are on the planet? There's quite a lot.
yeah, yeah. Is it 70 million?
I was going to say 7 billion, but I don't think that's quite
No,
right.
no, it's not billion. It's not million.
Yeah.
It's 700 million. 700
700
million.
million. Yeah. Okay.
Okay,
So
700 million.
a rounding error.
Yeah, yeah, 700 million. And we manufacture about 60 to 70 million cars a year.
Yeah.
Yeah, okay, in the world. So now, coming back to that question, I think it is very difficult to, when a technology has has been accepted, its utilization has been proven, its cost digression is coming year after year, it is very difficult to convince people to go after another new technology. So where fuel cells really have a chance today is if they can make it work on trucks, long distance trucks, class 8 trucks. And there's only a short window of opportunity, probably the next 10 years. If they don't get their act together, there will be more batteries coming in. And now I come to the question that you addressed regarding the battery packs. In 2006 to 2012, I used to tell my CEO, look, there are probably about 1 to 2,000 people working on fuel cells, but there are probably about 10,000 to 20,000 people working on battery electric cars. And the innovation of mankind, when you put in so much brain power, is going to lead to dramatic results.
Mhm.
And I come back to your question. Today, probably 50 to 60, 100,000 people are working on batteries, battery chemistry, etc., materials. And what we see with NMC today need not be there 10 years down the line. It could be metal sulfur or lithium iron
Right.
phosphate or something else. And I truly believe in the innovation generated by large groups of R&D engineers all over the world. So I'm not particularly worried about the sourcing problem, because the sourcing problem would also come with a hydrogen fueled car. Everyone seems to think it's pretty easy. It isn't.
Right.
It is just as challenging as the raw material supply of battery packs, probably equally challenging. But I'm totally convinced a lot of smart people, including you and me, if we are all working on these topics, one day we will come up with cool solutions.
Yes. Well, yeah. I mean, of course, I'm focused on the autonomy side, which we'll talk about. But the how you power these vehicles, of course, is a topic that affects us all. And when I don't know if I mentioned this to you, but when I was working with Neil Young, the guy who, the rock star icon who's been involved, also with creating sort of energy efficient vehicles as sort of showcases.
Mhm.
He worked with a gentleman from Wichita, Kansas, named Jonathan Goodwin, and he took a '59 Lincoln Continental and converted it to an electric vehicle, right? but with different ways to, it was kind of like a reverse hybrid. So it would drive as electric and then sort of recharge, I guess, recharge the batteries when the batteries kind of got low. But one of different fuel sources they experimented with was something called lipodiesel. Now I'm a germaphobe, and I discovered what lipodiesel was, and I almost left the project because it was actually they didn't actually experiment with it. They talked about it, and it's based on liposuction, that you can
Oh,
somehow
okay.
use that in the conversion of diesel. Of course, that made me
Okay.
physically ill, and to think about it.
Okay.
But it does speak to the novelty of hey, there's a lot of ways to get energy from substances in the earth, and so maybe there's a promise there with different ways to, certainly with batteries, right, to not just rely on the obviously the chemistry that we have today, but I'd be interested to see what advances there are, because it seems like there are limitations right now if you were to just try to scale with the technology we
Yes.
have right now. So,
Yes. Yeah, but I'm sure people will come up with cool solutions.
yeah,
And I do not negate the other thing that they are the research on alternate fuels,
yes, yeah,
biofuels, alternate fuels, etc. Generating fuels, synthetic fuels. They all add, and it is a competition. Uh, and right now, I think the competition will be that you would get new, newer battery technologies faster and scale them up as against getting alternate fuels in a reasonable amount of quantity to make an impact on world transportation.
yes, yes. Well,
Yeah.
so pivoting here for a moment, I guess, or into sort of automation. What brought you then from kind of what you were working on in the earliest days um, at Mercedes-Benz to automation, ADAS, and those types of technologies, connected vehicle technology, and sort of when did that transition begin to happen?
Yeah, I'll give you once the shorter version is that in 2006 when I took over uh, the Daimler Group research and traveled the world.
Hmm.
I had already traveled the world a lot. Being an Indian living in Germany, I was open to travel. And there's a rumor in the company that I was the best loved German abroad at the Mercedes-Benz dealerships, etc. So I did a tremendous amount of work for the sales and service organization and for the plants abroad. The reason for that was since I was a foreigner, I loved to travel, I loved to see new places, and I understood the differences in culture and thinking coming from India, settling in Germany, then going to the US, working with the American colleagues, with the Japanese, Korean, Chinese colleagues. I was hugely popular because I understood things. Let me make a point here. One was cup holders. Germans, Swabians especially said, no eating and drinking in cars. This is an expensive car, no cup holders. Period. And whenever I came here, the head of the Mercedes sales and service used to tell me, Bharat, this is our biggest problem that Mercedes does not have cup holders. And I used to go back home and tell my colleagues that, and slowly they caught on. Also, because on the JD Power studies, we took a terrific hit. Yeah. And at that time, the mentality in the company was you want to design cup holders, we will give it to an engineer whom we want to punish. And he'll design shitty cup
Yeah.
holders. And the initial cup holders of Mercedes were really bad
Right.
until we really caught on. We need to do something here because there are different cultural requirements and tastes abroad, which are totally different from what we in Swabia see as necessary for us.
What happened when you
So,
told them about big gulps and then super big gulps that from 7-Eleven
we,
here?
yeah, slowly we increased the size, and today we have pretty good cup holders.
Okay.
Yeah, they're not as big as the ones that the trucks have, but we are not going into the truck clientele.
Yeah,
Yeah, the Mercedes clientele typically takes smaller sizes, up to about 1 liter size, and that fits in comfortably.
yeah.
Yeah. So another example, and this is very interesting, Paul, regarding smartphone integration. Whenever I came to the US, my colleagues from the sales and marketing told me, "Bharat, we need a smartphone integration." My colleagues in Stuttgart told me, "Who cares? You're here for driving pleasure. You should drive and enjoy the car and not get distracted by smartphone and music." So, with my R&D group in Palo Alto, we developed, we initially went to Apple, and I talked to one of their high level senior VPs and later to Tony Fadell, but they were really not interested in supplying us with any sort of interface. They just gave us a software development kit, SDK. With that, we developed an interface, and that interface we had it manufactured by Mercedes-Benz Accessories. And my friend Ernst Lieb, who was the head of marketing and sales in USA, he tore open 200,000 cars per year in the US and retrofitted the kit supplied by Mercedes-Benz Accessories. And with that, all American customers could connect their smartphones and seamlessly use their music and safely access the music. Now, my current S-Class S550 has this still. And imagine we developed this sometime in 2008, and we are talking 2024. And last week, I took possession of a S580e plug-in hybrid, which has the Apple CarPlay. Apple decided many years later, because of the dramatic requirements, that they would supply CarPlay from their own company. And I use both cars, and the solution developed by my people is far superior to CarPlay and far safer. With CarPlay, whenever I want to select a playlist and a song in the playlist, I have to stop the vehicle on the side of the road, search for it on the menu, and then type it. People tell me, "Why don't you do Hey Siri?" But Hey Siri does not understand because I don't know the name of that song precisely.
Right.
And Siri tries to go into the cloud, etc. So anyway, now again I'm losing my train of thought. Our discussion was on.
Well, it was you were we were yeah, it did sort of transition from cups, no cups at all to okay, we'll get certain size cups, and people should enjoy the driving experience, which is interesting because someone who loves driving cars and makes cars is going to think, well, everybody should just want to get in and want to drive the car, but it's true that a large population of the world, they just want to live their lives, right? And what do they do in their lives when they're not driving? They're sleeping, they're listening to music, they're watching, something on TV, or playing a game with their children, or whatever it may be, and that's kind of what people want to do for longer trips. Ultimately, I would think, and it kind of brings you to autonomous driving, of
Yeah,
course, which
so
has to be
yeah,
safe, and maybe that's the sort of the connection. Maybe there was a
yeah,
resistance to, why would
yes,
anybody not
absolutely.
want to drive?
Yeah. So that was a strong argument that both Mercedes and BMW made, and BMW has it in its core value and brand value, the ultimate driving machine, and in German it's Freude am Fahren. It's the pleasure during driving. In 2006, so that's the first answer that I was trying to give, where I got distracted, sorry. In 2006, we had, from previous years, a very strong focus on safety, and we had a vision of accident free driving. So I got together my center director and two of my colleagues, one who's the VP of chassis and his center director, and a third VP on experimental verification and his center director. And I made a strong case and told them, if we have a vision of accident free driving, this translates exactly to a vision of fully automated driving. These are two sides of the same coin. And we had deep discussions on that. And after a month or two, all my colleagues were totally convinced. It sort of made click in their head. And starting sometime late 2006, we said we need to concentrate on autonomy, on also on higher levels of autonomy, because ultimately level 4, level 5 autonomy would also lead to our vision of accident free driving. And the entire company accepted this change in mindset. And we were really, Paul, we were far ahead of the game. In 2006, I had a group with about 130 engineers, and they were responsible for having developed the long range radar, the short range radar, etc., as also the stereo camera. There was only one company who could compete with us, that was Mobileye. Yeah. And we were ahead of Mobileye because we had cameras and radars. So we were not vested on only one technology. Yeah.
Right.
The good thing that came out of it was the entire company believed it, that we had to do something with autonomy because it went hand in hand with safety. And now I come to the second part of the question, when did it all start? And I have a short list here. Mercedes Benz was very vested in safety. And the first safety innovation that revolutionized the world came with the concept of the rigid passenger cell and the crumple zones. A very simple principle developed by an engineer at Sindelfingen, Bela Bereni, in 1952. We gave away these patents as also all other safety patents. And today it's the basis of all cars in the world, including the car that you and I drive. We have crumple zones in the front, the rear, now in the sides, and we have a rigid passenger cell which does not deform and protects the passenger and the integrity of the passenger space. Fast forward, in 1959, Volvo came up together with Autoliv, the seat belt.
Mhm.
That was also a tremendous innovation, and Volvo also gave off this innovation to the entire world. Then came the reactive systems, anti-lock braking systems. Mercedes-Benz and Bosch developed it in 1978, and I was loosely involved in the development from the simulation side in 1978. 1980, Mercedes-Benz and Bosch got out the airbag. And then the next reactive system, 1995, where my team was actively involved in the simulation, was electronic stability program. You know, electronic stability program corrects the heading of the vehicle through one-sided braking, was a tremendous innovation and a safety critical innovation, because you are applying one-sided braking suddenly without driver intervention to correct the heading of the vehicle.
Hmm.
All the systems that I tell you, the seat belt, the ABS, the airbags, ESP, etc., they were all reactive systems. That means something had to happen. You had to come into a dangerous situation. You had to have skidding, lose heading, or hit another vehicle or an object for these systems to deploy. The true change came, and that is the basis of today's autonomy, came with long range radar. I wasn't the head of that group, but it came from my group in 1998. Mercedes Benz and Continental developed the 77 gigahertz long range radar. And that revolutionized it, because with long range radar, we could bring out adaptive cruise control in 1998 in the S class. And it was not a fantastic performance. We could do from 20 to 90 miles per hour, and we had about 20% maximum braking. The big jump came when Conti and Mercedes in 2005, in the next generation S class, got out short range radar, 24 gigahertz, and we placed one radar at each of the four corners of the vehicle. And that led to a tremendous improvement in performance. So we could do adaptive cruise control from 0 to 125 miles per
Hmm.
hour. That's pretty fantastic. We could do 40% braking, and ADAS level 1 was born. Yeah. Then 2008, we had more courage, and we introduced 100% automated energy emergency braking, AEB.
Hmm.
This was 2008. And we had a cascading function there. And till today, there have been no false positives. We have had no
Really?
no cases, etc. till today.
Oh,
It's a very robust application. So the application that we put in, that's there in my cars also today, 2.6 seconds before time to collision, we warn the driver acoustically and haptically. 1.6 seconds before time to collision, we apply 40% braking, and zero point 0.6 seconds before time to collision, we apply full 100% braking. The reason for the cascading was 2.6 seconds before we would inform the driver, and if he were distracted, he could take action. He could apply the brakes, he could go off the throttle, he could swerve to the left or right lane, he could take control. 1.6 seconds, we knew he's not paying attention. Probably he's talking to someone at the back or searching for some fallen object in the footwell or something else. So when you apply 40% braking, he's going to wake up. He's going to push so strongly forward, he has to look up to see what is happening. He can still, in a passenger car, evade, swerve away, or do something else, or even apply the brakes himself. At zero point 0.6 seconds, we apply the brakes full because we know he's going to have a collision. Now you can question and ask, why not apply it much earlier? There is one critical use case. If you apply the brakes too early and don't have a collision, the guy behind you might rear end you,
yeah.
and he will charge you and say you brake suddenly in the middle of the highway.
Yeah.
And you have no proof that the other guy in front of you brakes suddenly also, etc., etc. So it was wiser to have a small collision rather than brake too much in advance. In trucks, we did 100% braking straight away because the truck has no possibility of swerving away or changing lanes at higher speeds to avoid a collision with the vehicle in front. And this was the topic we are discussing right now in the bus project. What sort of strategy do we utilize for avoiding hitting a pedestrian? Do we do the same philosophy as in cars and trucks, or do we need to do some other form of cascading because we have unseat belted passengers?
So,
Now, but coming,
just a quick
yeah,
question, if I could, because it's interesting. I guess there's this concept of this fixed time from when you sort of detect. It sounds like is it from when you detect the collision, or it's
detect.
the time to collision?
After you detect a potential collision,
Yeah.
you evaluate the time to collision at the current speed that you're going,
Right.
and
So
that's
so that
it,
1.6 seconds and 2.4 seconds isn't just
2.6,
2 point what? I'm sorry.
2.6.
2.6. That's just not. Is that just a fixed number, or is it based on the dynamics of the vehicle in some way?
We tested out a lot of use cases
Mm-hmm.
and finally programmed this.
Okay.
That is what is programmed in the older cars. Today it might be more tuned to the current speed, etc.
Right. Right.
But the
That's it.
seconds also give you implicitly the speed.
Right.
Yeah, because if it says 2.6 seconds, it also factors in the current speed that you are at and the distance of the object with which you are going to collide.
Okay. Got it.
Yeah. So coming back, then the big jump we had was in the next generation S Class 2013, where we got a stereo multipurpose camera, also developed by my group together with Continental. And this really brought in level two because we could do very robust lane keeping coupled with the radars with the adaptive cruise control. And this is the basis of all the current systems today, the radars and the cameras for lane keeping. In low end cars, you have a mono camera. In a Mercedes, you have a stereo camera. But the stereo camera also does object detection, etc. So it is a multi purpose stereo camera. It's used for lane keeping, lane departure protection, lane departure warning, high beam, low beam automation, and also pedestrian detection, pedestrian collision avoidance, etc. So it's multi-purpose. And now the last step that has come now, 2022, LiDAR. So the Mercedes-Benz is the first car in the world to get level 3 certification in California and Nevada with the LiDAR for certain areas of roadways on the interstate, which have been mapped in high fidelity so that you can do level 3 driving. Yeah.
I
So if
see.
you look at this entire system of safety and how it goes hand in hand with automated driving, we were very, very innovative on that point. There's Google self-driving cars, etc., but those are not cars you can buy,
Right.
and they are not certified for level 3 on normal roads or whatever. They are prototype cars in a very specific bounded zone which can be operated. And one of the key things where I convince my colleagues and the company is safety and automated are two sides of the same coin. Same sensors, same actuators, different algorithms and applications, with safety always taking precedence over automated driving or ADAS functions. So let me do a quick side by side comparison. On the safety side, you have autonomous emergency braking. On the automated side, you have adaptive cruise control, which also does braking and keeps a safe distance to the vehicle in front. On the safety side, you have lane departure protection. On the automated side, you have lane keeping assistance. On the safety side, you have blind spot protection. On the automated drive side, you have automated lane change. On the safety side, you have overspeed protection. And on the automated side, you have speed sign recognition
Hmm.
and automatically reducing the speed. Now, Paul, I was just in Germany driving my wife's new GLC 300E. It drives you crazy because Europe and Germany is mandating speed sign recognition and automatically changing your speed to the speed sign that has been recognized.
Oh, wow.
And this is terrible.
Yeah.
In city zones, every few hundred meters, you have a speed sign, and the system reacts to it and
Yeah.
replies to you with a gonging noise. And then if it changes from 30 to 40, it goes to 40, 40 to 20, it goes to 20. It is constantly changing speed.
And you can't turn that off? You can't turn that feature off in the car?
You can do manual driving.
Yeah. Oh, right. Okay.
You cannot do adaptive cruise control anymore. The
Yeah.
moment you put the vehicle in adaptive cruise control, it automatically changes speed all the time. If you try to overrule it, it starts warning you. It gives you three blink, blink, blink. It's constantly driving you crazy. At every new speed sign, it does blink, blink, blink.
Yeah.
And I hear this cannot be turned off, and the European Union is going to mandate it for all new cars.
Wow.
So anyway, that is on the automated driving.
Yeah.
On the safety side, it is over speed protection,
Well,
which is being mandated.
let me ask this. I mean, like, just kind of have a little paradigm shift. The story of I think it was like, I don't know if it was Kodak, when they were, they when the sort of digital cameras were being created, they're
Yes.
like, we're in the film business.
Yeah. Yeah.
And of course then they had to catch up with the digital camera sort of side of things, and then Instagram came along, and that sort of, they had this multi-billion-dollar valuation, and Kodak sort of did not,
Yeah.
and sort of faltered. And it was because, and someone, I forget who, it might have been Clayton Christensen or something, in his Innovator's Dilemma book, I think, maybe mentioned that they lost sort of a sense for what they were really doing. They weren't really in creating film. People didn't want film. People wanted memories, right? Pick
Yeah.
images and memories. And so similarly, within the automotive space, going back to sort of what those, your colleagues back in the day were saying, people don't necessarily, some people do, but not everybody really wants to drive. They don't want to drive a car, and they want to get to some location. They want mobility. They want to be transported from their home to work, or from their home to some location. They want mobility, and it's sort of given that that needs to be safe, right? They don't want to, they
Mm.
don't want mobility and have an accident along the way, right? So that's
Yes.
just sort of a given. It has to be safe. So it's not that they go out there and say we want safety. Like, that's just sort of a predetermined fact. It has to be safe, but they want mobility. They want sort of the freedom to live their lives again along the way. They want to be able to maybe take a take a nap, or watch a show, or read a book, or do some work, or whatever it is that they would be doing at their home or at the work at that moment, in the car, right? So that's, they just want to live, people want to live their lives, so they want mobility, and it needs to be safe, but they want to be able to have the freedom to do what they want to do. So really, automation, um, safe automation, obviously is key. And it's like, and so that's why I wonder, like, do people go out and buy these, did they go out and buy a vehicle because, and some people might, they have these ADAS functions, or do they really, or is it really just people want to go and buy the full automated package, and that's really what they're waiting for, and that's what's driving Tesla now, right?
Yeah, I fully agree with you. Paul, um, in the German system, we lost sight of what is the actual customer experience and what does he want. Certainly, some of us at certain periods of time want to drive a car and have the pleasure of actually driving a good car.
Mm-hmm.
Yeah. But I used to pose the question to my colleagues, and this was 2006 itself, where I told them, what pleasure do you have driving in a traffic jam? Each of you explain to me, what's the pleasure? Because I never had any pleasure. And Stuttgart today has become the traffic jam capital of the world,
Yeah.
certainly of Europe, because we have two huge construction projects, putting the main station underground and setting up a high-speed line from Stuttgart to Ulm. Tremendous. And that construction job is only going to be finished after another 5 years. And there is no pleasure in driving in such congested zones. Yeah. The second thing that comes up is, on American highways, you have sections where you're allowed 70 or 75 or 80 miles per hour. What is the driving pleasure there?
Yeah.
Yeah, holding my steering wheel straight, or what's the pleasure there? Yeah,
Right.
yeah. And that's part of the reason why Americans like cup holders and like to eat in the car. Because, in adaptive cruise control, you have time on your hands. There's nothing much to do. And I think Germans and the people are outside USA are finally understanding. You need to cater to customer wishes and implicit customer wishes. No customer is going to come and tell you, like the invention of the mouse. No customer came and said he wanted a mouse. You have to come up with some cool ideas, offer it to him, and then everyone today, none of us can work without a mouse,
Right.
be it a touchpad or a proper mouse. It's the same. Once you have a certain level of autonomy, people get used to it, especially with level three. I think level three will be very disruptive because if you can sit on the driver's seat, read books, watch a movie, but at the same time, in a certain period of time, say 15 to 20 seconds, take over control of the vehicle when it comes in an ambiguous situation, this will tremendously increase the experience of the customer. Of course, Google says, let's do the ultimate, let's do the robocar, you sit at the back. Uh, that is very convenient, but that does not really address my user experience that I want.
Right.
I still want to own my car. Once in a while, I still want to drive it.
Sure.
But many times in a traffic jam or on long highways, I want the car to do the driving for me.
Hmm.
And that's the transition that will come. And the car companies that address this wisely and correctly, they'll be the winners.
Yeah, and I think you're right too about like, certainly people who are used to living in a city, they might be okay with taxis and what have you. So the robo taxi business is going to be, as with everything, taxis exist in the non-autonomous world, they'll exist in the autonomous world, the robo
Yeah,
taxis. But people want to be able to get to where they want to go at the instant they want to get there, right? So they want to
yeah,
be able to walk out of their house, get into a vehicle and get to where they want to go. They don't want to wait 20 minutes, and they don't want to drive. Typically, a lot of people don't want to drive somewhere to wait or whatever.
yeah,
they,
yeah,
they, they want to get to where they want to go in the most sort of efficient manner, because time is life.
yeah, yeah.
And yeah, so but
So
as with
I
everything,
think,
people will still want to drive and feel the some people will still want to drive internal combustion engine vehicles because of the feel of the engine or whatever, unless you can sort of replicate that with the electric vehicles.
yeah,
Make
yeah,
it
yeah.
vibrate.
No, no, the other way around. I digress here because last week I got my S580e plug-in hybrid.
Hmm.
It's got a six-cylinder inline six-cylinder, 270 kilowatts with an electric supercharger and a turbocharger, 48-volt system, and it's got a 400-volt plug-in hybrid with a 28 kilowatt-hour battery. And Paul, you should come here. It's fantastic. That vehicle is fantastic. And now I come to your point. You can, on this vehicle at 70 miles per hour, go from pure electric to pure combustion and vice versa.
Hmm.
You will not hear any difference. The IC engine is as silent as the electric motor, as smooth,
Oh, okay.
no NVH issues. And I would challenge anyone to say, on what mode am I driving at 70 miles per hour?
Interesting.
So IC engines have caught up, tremendously efficient, and you have the best of both worlds. You can do electric driving, or you can do combustion driving. You can do a combination of both, etc. So there it's caught up. But let's come back to the primary driver. We all need to understand that customers have certain preferences at in certain situations. In a traffic jam situation, in a daily commute, my preference would be automated driving. If I'm driving to a pass to say Rocky Mountains from Denver, I would like to drive myself, yeah, and not have
Hmm.
automated driving. So as to have the driving experience, I think this would be the transition in the coming years, and whoever addresses it well would be the winner. And Tesla has really got onto it very well,
Hmm.
because I see so many Tesla drivers doing this full automated driving with their FSD suits, and that's typically for long distance driving very valuable because you don't have to pay that much attention. The system does most of the cognitive driving work. It's not as robust as solutions from traditional automotive companies, but that's a different story.
Right, right. Yeah, I mean, it's the you always hear about the edge cases and the scenarios that are going to crop up, and and how that's going to be addressable at a an accident or near accident free level will is still not within. Is the question is, when will that be within our reach for consumer automotive
Yes.
applications? I,
Yeah.
I don't know.
Yeah. What I can say is, at Mercedes, at Daimler, we had tremendously deep discussions. Whenever we got out a new innovation on the ADAS side, we had to find the proper innovation on the safety side. And sometimes we did the safety side first before doing the automated side. So let me make an example. Automated lane change. We had blind spot protection. In the initial stages, it just warned you of a blind spot. In my S class, it does one more thing. It also pushes you back with ESP, one sided braking, and pushes you back into your lane. So it not only warns you, if you don't heed the warning, it pushes you back into your lane. Now, this is a prereq if you're going to do automated lane change. In my new S580E, when I'm in level 2 automated driving, if I put on the directional indicators, the vehicle will also automatically change lane for me. But this needs to be backed up by the blind spot protection.
Mm-hmm.
So in case there's a vehicle coming with high speed from the back, it needs to the blind spot protection needs to take over, push my vehicle back into the lane, prevent any accident, etc. Yeah. And that's the interesting part with German engineers and their deep knowledge. They, whenever we had any innovation, we looked first at the edge cases, and it became a sort of competition. Who was the smartest guy in the room who could generate the most number of edge cases?
Right.
Yeah,
It could go
and
on and on. That could be a
yeah,
pretty
yeah,
big.
yeah, and then we had to sort it out and say which of these edge cases would be addressed and which reasonably uh, address the automated driving part. Let me make another example. Four-wheel drive steering. Now, four-wheel drive steering, typically a car, when you steer, you develop cornering force on the front axle because that's steered. The vehicle has to go into a yaw motion about its vertical axis so that the rear wheels also get cornering force. So basically, in all our normal cars, you have to generate yaw motion for the vehicle to build up cornering force on all four wheels. With a four-wheel steering, you generate cornering force at once on all four wheels. And this is a lane change with a four-wheel steering car is like driving on rails. It's tsak tsak. Yeah. No delays, no yaw motion, etc. But it comes with a catch. What happens if on the rear side the automated steering fails?
Right.
Yeah. Then you suddenly are building up yaw motion or you lose control of the vehicle, etc., etc. That's one extreme use case. During a maneuver, losing the rear wheel steering actuation. The other extreme use case is having a false actuation during straight line driving, which
Right.
is just as bad because you lose total control of the vehicle.
Right.
So my group, for the this false actuation, we can design it very, very robustly because we have experience with ESP. ESP, as you remember, is one-sided braking. And today you have probably over many 200 or 300 million cars, and there's no false actuation of one-sided braking because that also would lead to your total tailspin if one of the rear brakes locked. On the lane change, it becomes much more difficult. So my guys came up with a cool idea. They have two electric motors placed, I don't know, concentrically or in parallel, and both motors do the actuation. So if one motor fails, the other motor is also working and has enough torque capacity to do it alone.
Right.
So a motor failure, etc., is not going to influence it. A battery voltage failure is not going to influence it because they have some backup there, a local backup. And then let me go to the final example. I visited Daimler Freightliner Group, Daimler Truck in Portland. At that time, they had close collaboration with Google. So Daimler Truck, Freightliner prepared the vehicle from the mechanical side, and Google supplied the computers and the sensors and the software.
Mm-hmm.
And it's very interesting. Uh, the Freightliner Group, they had a twin power supply, totally independent of each other. For Google, they had three PC racks working independently of each other. The steering system was a twin system. The braking system was a twin system. The board network electricity was a twin system. So they had backup for everything,
Hmm.
including the throttle. And Google had a triple computer setup. And for the sensors, obviously, because of sensor fusioning, all that work. You have additional sensors so that you're surer of the objects you're detecting and your path planning, etc. And I think that's the way to go if you want to bring safe autonomy. You have to bring in redundancy, and you have to discuss upfront, step by step, how are you going to address the edge cases with the redundancy that you have.
Yeah. Do you see? So well, obviously agree, and then there's redundancy for reliability and then redundancy for safety. Those are two sort of different problems,
Yes.
right? Reliability and availability is kind of, you want a dependable solution, but for safety, you can stop the vehicle, right? If something goes wrong,
Yeah.
you detect a failure, you can slow down and pull over to the side of the road, or whatever the failure response is. Um, the have you seen much in the way of like diverse redundancy via like monitoring watchdog systems that are kind of like monitoring what's going on and then detecting um, an issue, and then when they sort of independent of everything else, and then when they sort of detect an issue, sort of making the vehicle sort of fail safe or kick out of the automated mode? Have you seen much of that in industry, or?
Uh, we certainly worked on it, and I would not like to talk about it, but
Okay.
we worked on it. So
Okay.
it was similar concepts to what you have in your vehicle. And I'm now 12 years out of the system. It has obviously progressed with all the technology that is available, both on the hardware side and the software side.
Yeah, and I
So
wasn't
I
just
believe,
referring to Mercedes. I'm just wondering in industry if like there's been much of that, because it seems like that, as just generally speaking, that's a useful function, right? To kind of
absolutely.
have something monitoring. I mean, it's been done in the to some extent in different ways in other industries, nuclear power plants and railway and what have you. But haven't heard much of it in the automotive space. The concept of sort of an independent, we call it a watchdog or a
Watchdog.
watch,
Yeah,
yeah.
yeah,
But
yeah.
yeah,
So what I can say is, when we saw during our visit your watchdog function, it was very impressive, and for me, very necessary if you're going into any level of high autonomy.
yeah, yeah. I mean, I think, yeah, from a production standpoint, at some point you need something like that. But it's hard. It's much harder for consumer auto to fail safe, on a highway because of that problem. If you're on I-95 or the 101, you can't just stop the vehicle, right? You have to gracefully kind of pull over to the side of the road. You
Right.
might be in the middle of like a 5-lane highway, so that might
Yeah.
not be as easy as said. But in a lot of our applications, geofenced applications, you can sort of stop and put the flasher lights on.
Yeah. So in with Freightliner, three of my students did one of the how do you when you go to a safe harbor and the system fails and you get the truck into the standing lane. There are other challenges, and one of the challenges is, in today's world, if a truck stops, he has to place these warning triangles at certain distances behind the truck,
Right.
and it has to be three and also offset. So my students designed for Daimler Freightliner multiple deployment solutions. So as the truck is going into emergency mode, shifting into the standing lane and slowing down, that it automatically deploys the warning triangles
Oh,
at
that's
the
great.
right lateral offset, and at the right longitudinal offset.
That's great.
These are very fine details which no one thinks of,
Yeah.
but which is necessary. After you stop the vehicle in a passenger car, I would say you need to open the trunk, because most cars have a warning triangle in the trunk. Put on setting on the flashing lights. That of course will be done at once. The moment you
Yeah.
detect the fault, on want to search for a safe harbor, you would switch on your hazard lights.
Yeah.
Yeah,
Yeah. But the physical sign, the deployment of that, or
yeah,
just redesign of the vehicle to enable more than just flashing lights. I don't know. Um,
yeah. You would need that. You would
yeah.
need more than that, because you as a customer, if you're stopping on a highway, I think there are expectations that you put a warning triangle some distance behind the car.
Okay. Yeah. Interesting.
For
Well,
trucks, certainly.
well, if we could just it's kind of a pivot, but it's very related. It's AI is well, it's always been a topic, and it's waxed and waned over 40, 50 years in probably in industry in general. I don't know about the automotive world, but and of course AI is a very broad term to mean many, many things, from
Mm.
simpler rule engines to knowledge based learning to, of course, a lot of people today when they say AI they think of deep learning neural networks. And now there's even, as you know, neural networks, the neural networks that sort of classify, like, I guess they're kind of like discriminative learning or
Mhm.
models. And then there's generative models like we see
Generative,
with
yeah.
the generative AI, which, is, you know, being applied a little differently. But I mean, what are your thoughts on I guess, can you relay any stories about sort of the earliest experiences with bringing even different types of AI into the automotive world, and
Well,
where you think it's going now?
at my time at Mercedes, we were strongly driven by deterministic algorithms, no AI.
Mm-hmm.
We were not willing to take the risk of going into a black box, which we did not understand. And even today, I would subscribe to that sentiment. You know, if you look at all mission critical applications, for example, rocket science, I've never heard of AI being applied for path planning or whatever when you send off a rocket. I've never heard in a aircraft AI being applied for control systems.
Mm-hmm.
Now suddenly we say we can do AI on cars. And my first question is, why aren't other people doing it in other high-tech areas? Is there a reason? My thinking is yes. In mission critical applications, you want 100% certainty that the system does work the way you have designed it for the use cases that you have designed it. And that's the way we at Daimler program the systems. Yeah. Now, AI has changed dramatically in the last few years and will, especially with generative AI, and will also change even more dramatically. With AI solutions, in the earlier years, we looked at AI solutions for certain parts of the automated driving suite. For example, for object detection and classification, object classification,
Mm-hmm.
yeah, where AI could help in making it a more precise classification. And there I would go along with it and say, yes, that could make a lot of sense. But today, what I hear from Tesla is they want to do AI from the front to the to the other end, the complete chain to be done in AI with deep learning and blah blah blah. The question I always ask is, what are the safety tests today for conventional level 2, level 3 vehicles, regardless of whether it has AI or not? What is the certification for that? And I know of no proper certification procedures how we want to do it. NHTSA has just now brought out a rule regarding automated emergency braking for passenger cars and light duty trucks. But that is for braking, that is the safety side, that is not the automated side. What sort of performance metrics would you write down to say this is a level 2 driving or this is a level 3 driving? What are the edge cases that you would prescribe? It's very interesting to see in the reactive safety side, which I had explained earlier with the airbags and the ABS and all that. There you have enough metrics. For ABS and ESP, you have J turn, etc. For crash, you have multiple levels of crash with offset at multiple speeds, etc. All prescribed where the OEM does the test and validates it and supplies the results to NHTSA.
Mm-hmm.
For automated driving, I do not see it. And now we come to the next step. Someone comes to you and says, "This is my car. I've driven it for 5 years. It's done a lot of deep learning. And now it's at a fantastic new level of automated driving. How can I trust this car? What did it really learn? And who's going to tell me that it's learned something good?"
Right.
You can also teach an automated driving car to drive aggressively, because everyone else will react to this aggressivity and slow down for it. If you come to a circle, if you come in as the first and drive in aggressively, most other people will stop for you. That could also be part of the learning experience, that the automated car says, "I need to drive aggressively into crossings because I'm sure others will wait for me." So, there is no metric of what deep learning has led to. The conventional wisdom is going to be something good.
Right.
I would not trust it that way
Right.
unless someone proves to me in edge cases that it reacts better than what I have programmed deterministically in my algorithms.
Right. Yeah, I mean, it's the classic, how do you verify and validate or certify, however you want to refer to it. I guess they're different sides of a similar coin. I don't know, is that the right term? But how do you verify and validate that it's correct and complete? And that's not doable right now. And then I guess the question too is, when you start to look at, like, if there's an accident and you try to sort of figure out, like, what line of code or what caused this
Mm,
failure, hardware or software. On the software side, you can't look at neural network weights, which are just a bunch of numbers,
mm,
and say, oh, this number instead of 4.5 should have been 4.7. Let me just change that, right? I mean, that how do you verify and validate and then inspect what went wrong? Because it's all probabilistic. It's all based
mm.
on, like, probabilistic prediction of what an output should be, right? And it's a probability function. And how do you prove that? I mean, I don't know. I ask everybody probably this question because I'm curious, and I'm getting the answers like you have, which and yours is was more eloquent with respect to, yes, determinism is so key. And you want to know from a production standpoint how this vehicle is going to operate, because you have children and your loved ones in these vehicles with you, and the people have their loved ones in their vehicles, and you want to know that this thing is safe. And how can you know that when you can't know what decisions it's going to make on a probabilistic basis?
Yeah, at a very basic level, Paul, I agree with you. At a very basic level, you need to do a lot of edge case setting tests. You set it up with soft dummies, etc. And we have done this all. And it's a lot of effort and work. And sometimes companies like to take a shortcut and say, okay, we'll just push it out and we'll learn from experience. If a customer has an accident, we'll evaluate that and we'll tweak a line of code or whatever. Or we'll say this deep learning algorithm wasn't good enough, we'll put in another one and see where it takes us.
Yeah.
It's a hit or miss approach. And for me, the first step is some common understanding of mandates, like in passive safety. In passive safety, it is all mandated what sort of tests you have to pass. In reactive safety for ABS, for ESP, it is also all mandated. Now, in the proactive safety, self-driving safety, automated driving, you need to set up a number of tests where you say the system needs to successfully navigate these tests, where you can say, okay, then we can certify it as a proper level 2 or level 3 or whatever.
Yeah. Yeah.
And the system performance, the new Google accident that happened, the car did a lane change, and the car that came from the back was driving at a speed higher than allowed, and that's why they had got into an accident.
Yeah.
Yeah. Now, that's something I would like to know upfront. When you do a lane change, automated lane change maneuver, what are the limits to the speed differential to your vehicle for a vehicle coming from the back? Is it 20 miles per hour? Is it 50 miles per hour? And I'm sure Google has never tested that.
Yeah.
And I'm sure my colleagues have tested it in the automated lane change. And they have a precise number, if, whatever the number might be, whether it's 35 miles per hour speed difference or 40, and then they'll say beyond that, the system will not function correctly.
Right. Right. Yeah.
And if it detects that, it needs to go back into its lane.
Right. Right. Yeah. I mean, it's a tough one, and then generative AI is going to be an even more interesting problem with how it's applied. I mean, there's ways that I think it can be applied for it to be useful, as with any technology, but then there's going to be ways that people apply it that's just going to be fraught with peril, and
Yeah, yeah,
it's
fully agree,
yeah,
fully agree. Just like in the normal application of generative AI, etc., there'll be a lot of good applications, but there'll be tremendously bad applications.
yeah.
Yeah, nefarious people who want to do evil, etc.
Well, I wasn't even thinking about that, but that too. I was thinking of just people misapply, well-meaning, well-intentioned organizations who want to apply it because they think it can help, or to some engineers, it's the new shiny object, and they want to learn how to use it and play with it and apply it, and they think it's a new silver bullet, but it's not, for autonomous driving, at least. I don't, but I think there's some advantages to it that we could discuss. But I think, yeah, there's, yeah, it's gonna be interesting to see what happens. And again, at scale, how do for like for a small subset of vehicles? Now, Tesla has a large footprint of vehicles, so this doesn't apply to them. But for, it's one thing to test it out and try it out. Um, like, I consider what Google and Cruise were doing as a smaller subset of vehicles.
Yes.
um,
Yeah.
but yeah, at scale, how are you going to verify and validate that? And I still think, yeah, Google and Cruise should probably still have operators in the vehicle.
Yeah. Yeah. So, Paul, let me take it to another extreme. The way I see it is these new innovative companies, when they talk about AI in automation, self driving cars, basically they're looking for a shortcut. I write a reasonable amount of code, which is deterministic, and then I hand it over to some AI system, which will take it to the next level.
Yeah,
And for me, it is cutting corners, cutting effort, putting the burden of proof on the end customer, where you then constantly evaluate the performance. And if he has an accident, you evaluate why it happened and tweak some parameters or write a bit of new code, etc., and go into it. Now, I might be misjudging Google, but I'm sure they'll be looking at a new bit of code which looks at the speed differential of the vehicle coming from the back. And if it's over a certain limit, to stop the lane change and correct it and bring it back.
yeah.
Yeah.
Yep, yep.
Yeah. Now you can keep on doing that. The world of accidents is more and more complex, and the way the systems react to it and the vehicle dynamics also changes over a period of time. So the software code that I had for my current key vehicle, would it transfer with the AI generated into it into the next generation? Question mark.
Yeah. Well,
Big question.
well, kind of related to this, and as we're getting to, towards the end of our time here, I want to ask a couple questions, because you're, that might apply to aspiring students and folks who want to learn how to get into this world, into the space that we're in, and now they're confronted with. I got it's always got to be difficult for each new generation because now there's this generative AI sort of golden golden egg that's just out there that everyone wants to get their hands on and work with. Then you hear some people saying, in the future we're not going to have a need for computer science engineers because it's going to be able to generate. It does generate code pretty well, you won't have as much of a need or any need. What should those students and just people who want to get into this world of automotive engineering and just and automation of automotive applications. Any thoughts on what they should be sort of directing their energies towards and
I,
how they can succeed?
I truly believe, Paul, you need a good engineering foundation, a good software foundation, need to understand how to write algorithms, need to understand their limitations, etc., and then take the next step and use a bit of AI to take it to the next level. If you start the other way, which is what is being suggested in today's world, just some basic knowledge of the engineering problem you're trying to address, and a lot of knowledge of the AI, and just push in the AI and it'll generate something cool for you. I think that's a dangerous path to go down. So
Right.
I would advise everyone, get your engineering foundations clear and then learn to apply AI to the type of problems that you will be working on, because your engineering knowledge will determine the quality of the end results coming out of the AI. And that's also, if you look at Chat GPT, it generates a lot of good text, but ultimately it's you who feed it the keywords and who edit what it writes and spits out.
Which makes me wonder. I used to work at Harris Corporation, which had many systems engineers, right?
Mm.
And they were very focused on writing really great specifications and requirements, and really a lot of talented people who were very good at that and writing correct and complete specifications. And how do you do that? And in some ways, interfacing with Chat GPT and these other tools, or some people might refer to it as well, I guess I've heard the term prompt engineering, which is a little different, but you have to give it good specifications and inputs for what you want. And so maybe having a good systems engineering background and knowing how to articulate what what should be done, not just how, but what should be done. And then also engineering is how it should be done. Because maybe these tools aren't going to produce good outputs as to how something should be done. Um, and I guess I just think that, yeah, maybe that's having a sol maybe a stronger foundation in systems engineering and requirement specification will become important in the coming years. I wonder.
So you put it on systems engineering. I would put it as having a strong engineering foundation, regardless of whether it's computer science, mechanical engineering, electrical, etc., and then
Yeah.
applying AI in whatever form to solve your engineering problems. Yeah, a systems approach, yes, it'll help you more, but my my fear is that people will say a certain amount of basic coding knowledge is enough, and then I go into generative AI and it'll do all the coding for me.
Right.
And there's a new ad playing on TV now, right now on TV, which says you have to redesign code, and you're spending days and night in the office redesigning that code. Just give it to some generative AI that I don't know the name of the company, but it comes on every day in MSBNC and in CNN, and it'll do all the code generation for you.
Yeah.
Yeah.
Well, it's amazing as to what it can do now. I will say that,
Yes.
and
Yes.
it's going to get a lot better faster. So,
Paul, it's amazing and also scary,
yeah.
because what we don't know is in what area has it screwed up.
Right.
Yeah, you'll only know it after you apply it, and then someone will say, "Oops, I didn't look into this corner," or the information that I fed into the system led to some other form of ambiguity, etc. As long as it's not mission critical, we'll just shrug our shoulders and move on. When it becomes mission critical, all you'll hear is, "Okay, you'll get a software fix."
Right. Right. And a lot of people are using it not in our way where it's interfacing with the physical world.
Yeah,
They're using it, just to create a press release or something that's,
yeah, non-critical
not
applications.
non-critical, but something that's connected to the physical world that's going to control, a steering wheel or a throttle that could affect the safety of the vehicle is dramatic. So,
In all my talks about automated vehicles, I always finish off with a spoof. Would you like to hear the spoof? And if you do, you can you can I can send you the sound file,
okay. it's
and I
it.
can modify it to include Perron robotics. So I'll just play it.
Yeah.
The Dallas Morning News, April 1st, 2044. Self-driving vehicle crash outside Collin College, Frisco campus, North Texas. A crash between two self-driving vehicles occurred outside the Collin College, Frisco campus at the intersection of Ohio Drive and Wade Boulevard. A Google car was in a rush to attend the IIT North Texas 2044 conference. The orange car at that time did not clear the intersection even after the lights had turned red. Before your reporter could reach the scene of the accident and record this historic incident, and even before Mr. Elon Musk could tweet about it, the Google car and its rival, an orange car, self-drove themselves to the sheriff's office, and from their event data recorder downloaded through e-complaint technology differing versions of how the accident occurred. The orange car alleged that the Google car was driving aggressively in supersports mode and lost control. The Google car vehemently denied these allegations and countered that the orange car was at that time downloading new software and thereby distracted. It cited a witness, a Mercedes-Benz self-driving car in safety-first mode, which cleverly avoided both colliding cars. Both cars' occupants were uninjured and slept peacefully throughout the entire episode. The case will be tried at the Dallas, Texas E-Trial Court Number 12, where its computers will be rebooted to prevent any liberal or conservative bias. Two Cray supercomputers will be defending the Google car. The Orange Car Company will have its own array of massively parallel microcomputers representing the plaintiff. The Mercedes-Benz car will be invited as an expert witness. If found guilty, the Google car would face a maximum penalty of 5 years immobilization. For humanitarian reasons, its V2X system would remain enabled. The defendant would need to purchase and drive a Mercedes-Benz car during that period. Should the case be dismissed, the court might impose a penalty for the orange car that would involve no software updates for an entire year, far removed from the current practice of 2 per day. Regardless of the case outcome, the R&D engineers at Google and Orange will be mandated to take courses at the University of Alabama, formerly known for its football team and today the most prestigious university in the southeastern U.S., to finally learn the electrical and electronic software and hardware design and validation process.
Okay.
So is that a deep fake or was that generated from generative AI?
I wrote it.
Oh, okay,
I
you
wrote
wrote it. Okay, so
I
it's
wrote it. I wrote it. Yeah, I have multiple versions of this, and all my talks. If you like it, I will modify it for a crash outside the Perrone Robotics headquarters.
please do, please do. I'll share it with the team and see if
Yeah,
they.
it gives a lot of laughs. Yeah, and then add some words to Perrone Robotics also here.
Yes, yes. Well,
Yeah,
that's fantastic. That's great. Well, Dr. B, thank you so much for your time here today. This has just been great. I mean, I've learned so much, and the people who have dialed into the show will have learned so much. And who knows, maybe Elon Musk and will dial in since he's prominently mentioned and admired.
And admired, yeah.
So, but thank you for everything you do, and it's so wonderful working with you, and of course, always talking with you. Thank you, Dr. B.
Thank you.
I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web, and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.